So today we're going to be working through some Further Stats 1 revision, and this is the first chapter in the Further Stats 1 book. So we're looking at discrete random variables. So we're working through using this textbook. I've picked a few questions out, and then I picked an exam question out off the old spec. So let's have a look at this. So first question is from exercise 1A, question 5. So let's get my pen. So we've got discrete random variables, and we have the random variable x, which has the following probability distribution. So what it's doing is we're going through x 1 to 5. So when x is 1, the probability that x is 1 is 0.1. When x is 2, the probability is a. When x is 3, the probability is b, for example. Okay, so we're told e of x, so this is the mean, so e of x is 2.9. We're just asked to find the value of a and the value of b. So remember, to work out the expectation, the mean, all you do is you take your x value, so x is 1, and then times it by the respective probability, so 1 times 0.1. So e of x, this is 1 times 0.1, plus, and then keep going along, 2 times a, plus 3 times b, plus 4 times 0.2, and finally 5 times 0.1. Okay, now we know the e of x, the expectation, is equal to 2.9. So if we make that equal to 2.9, what we can do is we can simplify it, and let's see what we end up with. So 1 times 0.1, 0.1, that'll be 2a, that'll be 3b. 4 times 0.2, that'll give me 0.8. And then finally I'll get 0.5. Okay, so let's keep simplifying here. And again, this is still equal to 2.9. So that's 0.9, 1.4 plus 1.4 is equal to 2.9. So we can take that 1.4 across and we get 2a plus 3b is equal to 1.5. Now, because this is in terms of a and b, we can't solve this just yet. So we need to obtain another equation, and then we can solve simultaneously. So what other equation can I obtain? Well, remember, for a probability event, the total of the probabilities, so the sum of them, should add up to 1. So, respectively, what that would be is 0.1 plus a plus b plus 0.2 plus 0.1 is equal to 1. Okay, so that's the sum of the probabilities. So 0.1 plus 0.2 is 0.3 plus 0.1, that's 0.4, so a plus b, that would be plus 0.4 equals 1, so I'm going to take that 0.4 across to give me 0.6. So now I've got two equations. I've got equation 2 and I've got equation 1. And I'm just going to solve these simultaneously. So I'm going to multiply equation 2 by 2. So I'm going to get 2a plus 3b is equal to 1.5, changing nothing with that one, times equation 2 by 2, so make sure you multiply everything, 2a plus 2b is equal to 1.2. And then finally, because these coefficients of the a now match, we can start solving. So I'll be subtracting here, so 3b minus 2b gives me b, 1.5 minus 1.2 gives me 0.3. So because b is 0.3, we can now solve a dead easy. Because we know a plus b is equal to 0.6, so therefore something plus 0.3 is equal to 0.6, so a must also be 0.3. And there we have it, so we found the value of a, 0.3, and b is also 0.3. So a bit of a nice question to start with, 5 marks there. Let's have a look at the next one. So the next one's pretty similar. We've got another random variable x here with this probability distribution given below. And part A asks us to write an expression for e of x in terms of a and b. And then part B tells us that given the variance of x is 0.75, can we find the values of a and b? So part A, hopefully nice and straightforward. To write down an expression for the mean, the expectation of x. Remember, like we just did before in the previous question, we do our x times by the probability and sum those up. So that's going to be 1 times a plus 2 times b, finally plus 3 times a. So let's collect all these terms together now. So that's a plus 2b plus 3a. So therefore 2b plus 4a. Or really, I should write that as 4a plus 2b. Looks a little bit nicer there. In alphabetical order, so 4a plus 2b. So we've got the e of x there in terms of a and b. Now, for part b, it says given that the variance of x is 0.75, can we find the values of a and b? So, remember, the formula for the variance of x, so variance of x, that is e of x squared minus the expectation of x all squared. Okay? Now, first, let's consider what happens when I add these probabilities up. So, like we just said in the previous question, the total of these probabilities should equal 1. So, I'll do it again. Sum should be equal to 1. So, a plus b plus a is equal to 1. So, that means 2a plus b is equal to 1, right? So, notice we can actually form a connection here now between the mean, the expectation of x, and my total, the probabilities. Because 4a plus 2b, well, you can factorise this. So this would be 2 lots of 2a plus b. But we know 2a plus b is 1 from this line of work in here. So 2 times 1 is 2. So what we know is that e of x is equal to 2. Okay, so we know e of x is equal to 2. Now, we can work this out. So, e of x squared, so all that means is you square the x values and then times. So just like we did with the mean, but square the values first. So, if we do that down here, so that's going to be 1 squared times a, so that's going to be a. 2 squared, so that's 4 times by b, so 4b. And then finally, 3 squared, so that's 9 times by a, so I get 9a. Okay, so that's my e of x squared. And then we need to subtract e of x all squared off, which is 2. So subtract 2 squared. And we know this is equal to 0.75. So that's my formula for the variance, which we know is 0.75. Collect like terms here. So 10a plus 4b minus 4 is equal to 0.75. So now I can simplify again. So this will be, do it over here, 10a plus 4b is equal to 4.75. So we've got 10a plus 4b is equal to 4.75. Now we need to solve simultaneously, just like we've done with the previous one. When you're doing discrete random variables, a lot of the time you're going to be looking to solve simultaneously. It's a big key to solving these questions. So, notice we had 2a plus b is equal to 1. So, if I multiply this, if I call this equation 1, and I multiply it by 4, so this is my equation 2, we can solve simultaneously then. So we've got 10a plus 4b is equal to 4.75. We've got 8a times it by 4 plus 4b is equal to 4. So because the coefficients of the b match now, we can subtract. So 2a is equal to 0.75. And if you divide by 2, that would be 0.375. Now because a is 0.375, we can now solve for b. So 2 lots of a, so 0.375 times by 2. We already had 2a, so that's 0.75 plus something is equal to 1. So b must clearly be 0.25. Okay, so hopefully that's not too bad, and hopefully the previous bit of work in there makes sense. So that's question 7 done from exercise 1b. So let's keep going. So the next question is from the old Edexcel spec. So this was the previous maths specimen, and this was just the A level. So this actually used to be only an A level topic, and now it's moved on to further stats 1. So Pi just asks us to write down an equation in P and Q. So if we've got, again just like we did with the previous ones, my probabilities here. So P, Q, 0.2, 0.3 and P. What we just said, the total of these probabilities should be equal to 1. So I can simply just obtain an equation in P and Q by adding these up. So that would be P plus Q plus 0.2 plus 0.3 plus p. And simplifying, that would be 2p plus q plus 0.2. In fact, add 0.2 to 0.3, so that would be 0.5. And we know this should be equal to 1. So therefore we can just subtract across, so that would be 2p plus q is equal to 0.5, or a half. Okay, and that's simply just an equation in p and q. You don't need to do anything else, it's as easy as that, and that's why it's just 1 mark. Part B now, so we're given that the expectation is 0.4 for x. It just wants us to find the value of q. So remember, just like we did previously, do your x value and then times it by the corresponding probability. So that would be minus 2 times p plus minus 1 times q. So I'm kind of hoping I'm not running out of room here, but I might do a little bit, plus a half times 0.2 plus, so I'll just do it underneath, 3 over 2 times 0.3 plus 2 times p. Okay, so this is my expectation of x, and this should be equal to 0.4, all of this. 0.4, that is 0.4. So let's simplify here. So this is minus 2p minus q. Half times 0.2, so that's 0.1. 3 over 2 times 0.3, so that would be 0.45. And then finally, we get 2p. And this should be all equal to 0.4. Well, if you've got minus 2p and a positive 2p, they will just cancel. I've got minus q plus 0.1 plus 0.45 is equal to 0.4. So let's write that down. So that is simplified to 0.55. That's equal to 0.4. Well, this is minus q. I want it in terms of q, obviously, so I'm going to take that minus q across and take this 0.4 onto the other side as well. So add q and then subtract 0.4 from both sides. So I'm going to get, therefore, that q is equal to 0.15. And it's as easy as that because the p's cancel. But now we can work out the value of p as well. So part C. So hence find the value of p. Well, if we use, so using what we previously had here, so 2p plus q is equal to 0.5. 0.5. Well, if q is 0.15, like so, 2p plus 0.15 is equal to 0.5. I can subtract here to give me 2p is equal to 0.35. So therefore, p is equal to 0.175. As easy as that, you're just using your formula that we got, so 2p plus q is equal to 0.5, and then sub your q value in, and just solve from there for p. So that's p equals 0.175. And then finally, part D here, we're given that the expectation of x squared is 2.275. So we've got to find the variance of x. So remember the formula for the variance. That's e of x squared minus e of x all squared. And this is equal to, oh, we're not given the value what it's equal to, we're just given e of x squared. So we need to work it out. So we're given e of x squared, that's 2.275. We have e of x somewhere, where was it? 0.4, there we go, I couldn't see it then, 0.4. So if we square that and then subtract it off, what we'll get is that the variance of x, so just put this on your calculator, you'll get 2.115. And there we have it, so that's the final 2 marks there for this question. So this was an actual exam question, so it kind of gives you an idea of how many marks would actually be given for these kinds of questions. And then finally, let's move on to the very final one. This is from the mixed exercise 1 now, question 9, from the Further Stats 1 textbook. So, we're given a random variable x with this probability function. Part A just asks us to find the value of k. So part A, so like we were just saying, when you add all the probabilities, you should get a value equal to 1. So when x is 1 or 2, it works with the function here kx. So when x is 1 or 2, that's what function it is. And when x is 3, 4 or 5, it's k multiplied by x minus 2. That's 3, 4, 5. So I kind of cut off the k there, but that's k multiplied by x minus 2. So for example, if I do my table now, so I'm going to construct my own table just like we had it in the previous ones. So let's just say when x is 1, 2, 3, 4, 5, and then I've got my probability values here. So when x is 1, for example, that would be k times 1. So that's just going to be k. When x is 2, again, I'm working in this function here, kx. So when x is 2, that's going to be k times 2, or 2k. When x is 3, so be careful now, we're using this formula this time, this function. So when x is 3, that's 3 minus 2 times by k, so that's 1k, or just k. Again, this function again. So when x is 4, 4 minus 2 is 2, times by k, 2k. And then finally when x is 5, 5 minus 2 is 3, I get 3k. Okay, so the sum of these now should be equal to 1, so should be equal to 1. So if we add all the k's up, so k plus 2k plus k plus 2k plus 3k, this should be equal to 1. So 3k, 4k, 6k, so that's 9k in total. So 9k is equal to 1. So simply, to get k, just got to divide 3 by 9. So k is equal to 1 over 9. So we've got the value of k. Part B wants us to find the exact value of the expectation of x, or the mean. So try and do it over here. So we should have enough room, I think, for this. So there's two ways of doing it. You can use your table again, like we've got here, and actually replace your k's with 1 over 9. Or you can keep your k's in, multiply it across like we would normally for the expectation, and then at the very end switch your k. So I'm going to do the latter. So I'm going to do keep my k's in, multiply, and then change it at the very end. So it's 1 times k plus 2 times 2k plus 3 times k plus 4 times 2k plus 5 times 3k. This should be equal, in fact we don't know what this should be equal to yet, so let's work this out. So that's k, that's going to be 4k, 3k, 8k, and then finally 15k. So I've just literally done all my multiplications here, and these are the respective values. That should be a k though, 15k. So let's add these up. So that's going to be 5k, 8k, that'll be 16 plus 15, so I should get 31k. So e of x would be 31k, but we want the exact value of e of x, and k is 1 over 9, so 31 times 1 over 9, that's the same as 31 over 9. And there we have it. So that's the e of x, the expectation of x there, 31 over 9. Now part C, pretty similar. Remember the formula for the variance, so it's going to be e of x squared minus ex all squared. So what I'll do is I will, in fact I'll erase it all. So we should be able to, in fact I'm going to just erase this bit over here. We'll just go to this bit. I should have enough room to do it over here. Get rid of all this. So for the variance, so if I start up here in the corner, so the variance of x, I need to square my values first and then multiply. So for example, 1 squared, so that'll be 1 times by k. So that'll be k. 2 squared, that's 4 times it by 2k, so that's 8k. 3 squared times by k, so that's 9 times by k, so 9k. 4 squared is 16, times that by 2, I get 32k. And then we're on to the last one. 5 squared is 25, times by 3, I get 75k. So now this would be my e of x squared. What I need now for the variance is e of x squared minus the expectation of x squared. Okay, Now we know the expectation of x, that's 31 over 9. We know e of x squared is this, so if I simplify this, this will be 125k. So 125k. So literally all I've got to do now is replace this with my 1 over 9. So that's 125 over 9. So that's a 1, believe it or not, I kind of butchered that one, but 125 over 9. So my formula now is just going to be e of x squared. So that's 125 over 9 minus 31 over 9 all squared. Put this in on your calculator, and what you will get to three significant figures is 2.02, like we're asked for. So we know we're definitely right with that one. And then clearly my e of x is right, so you know the previous working is all correct. So finally, for the very last mark here, part D, we should have enough room if we do down here in the corner. What we're looking for is the variance of 3 minus 2x. So remember, these questions are really easy. All you do is look at your coefficient of the x here. So it's minus 2. So what you do is you pull that out. So it'd be minus 2. You square it and then multiply through by your variance. Multiply by the variance of x. It's as easy as that. So this is minus 2 squared, so that's 4. Times by the variance of x, which is, they've already given us, is 2.02. So even if you couldn't actually show that the variance of x was 2.02, you can still attempt the question. Okay, multiply this and then take your answer to one decimal place, and what you'll simply get is 8.1. So that's to one decimal place. Okay, and that's finally that question done. So I hope this has been helpful. And that was just a quick video there on discrete random variables.